pleasure to welcome you to the first Campbell Centre research seminar of the semester. I'm Georgia Mason in the Department of Animal Biosciences, and myself and Lee Neal from Population Medicine are organising the talks for this semester. And this first talk is a joint venture with the Central Animal Facility, so we've jointly sponsored it because our speaker is also involved in a rat tickling workshop tomorrow. So the CCSAW seminars are just going to be the same as they have been for the last few years because it seemed to work so well. They'll be once a month. They'll be the last Thursday of every month in this room. The one little change that Lee and I have implemented is that we've asked the speakers to allow more time for questions in this room. So as Megan speaks, start thinking of all the things you want to ask her because there'll be discussion time at the end. Okay, so without further ado, it's my enormous pleasure to introduce Megan LaFollette, who is doing her Ph.D. at Purdue University under the supervision of Brianna Gaskill and Maggie O'Hare. And she's working on the welfare benefits of tickling rats, something she also did for her master's with the same advisors. It's a particular personal pleasure for me to introduce her because she's actually my first academic great-grandchild, in that she's my first PhD student's first PhD student. Someone asked me if this made me feel old, but it just makes me feel fantastic. I have to say, so Megan, it's really great to have you here.
Awesome. Thank you, Georgia, for the introduction. I'm really excited to be here too. And I'm going to walk you through some background about what rat tickling is, about two different studies I'm going to outline. One is about reviewing research, and the other is about determining dosage for rat tickling. But I'm going to start off a little bit bigger picture. Right now, the use of animals in research, as well as all around in all sorts of use, is facing public scrutiny. A relatively recent Pew poll found that about 50% of Americans oppose the use of animals in scientific research. Research itself is also facing a reproducibility crisis. In a poll by Nature, about 70% of scientists have failed to reproduce at least one other scientist's experiment. And research is also facing a translation crisis. About 90% of drugs that enter clinical development will fail to gain FDA approval and actually move to market. This is an unfortunately grim picture of animal research right now. The reasons for this are multi-factor. I'm not going to pretend that rat tickling or animal welfare is the one solution that's going to fix all of research problems. But I do believe that animal welfare will play a part, and that animal welfare is important for improving science by thinking about the cost-benefit ratio. So when we do a research project with laboratory animals, we want to think about the costs of that research, how the animals are actually going to be harmed, but also the benefits. So what likely results might we get? How may they help humans? How may that help the greater knowledge? And it's possible that animal welfare will hopefully decrease those costs of the animal, but also increase the benefits by helping our animal models be more reliable, be more accurate, and help that translation process, and potentially even help a little bit with reproducibility by adding in some inherent variability into our models, which can actually be good in the long run. So for those of you who may not be familiar with animal welfare, just to get us all on the same page, a lot of people have different ways that they think about animal welfare. And there's three main ways that people think. First is biological functioning. So this is thinking about the health of the animal, its state of disease or health. The second is natural living. So is the animal able to perform behaviors that it is highly motivated to perform and would perform in the wild? And then the final one is affective states. And I would actually argue that this top one, this affective states component, is the most important one. This is how the animal feels, whether it's experiencing suffering, whether it's experiencing pleasure. But ideally, we want to enhance animal welfare by finding something in the middle that really promotes all three of these conceptions, and that is going to, in the end, help everybody with different thoughts about how welfare should be enhanced, hopefully reach a happy place. So I'm going to talk a little bit more about affective states to begin with. So when we think about affective states, we can think about them on a quadrant. And if affect is another word for that's similar to emotion. So affect can happen on one axis from positive valence, so these are positive emotions, to negative valence. On the other axis is arousal, from high arousal to low arousal. And I'll give you some examples of what we experience as humans so that you can then relate it back to animals. So we may be feeling a highly aroused but of negative affective states if we're really, really afraid and fearful. So if you're walking down the street and you're afraid that you're going to get robbed, that's probably what you're feeling. Your heart's pounding, it's racing, you're really amped up, you're scared, and it's not a good feeling, but you're highly aroused. On the other hand, you can still have that same type of high arousal. Your heart is racing, you're really pumped up, but be of a positive valence if you're, say, at your favorite rock band's concert. You're jumping around with friends, you're certainly pumped up, but it's a positive feeling. On the other end of the spectrum, that low arousal, negative valence, a classic example would be feeling depressed, feeling like you're not feeling good, you're feeling bad, you can't get out of bed, but you're very, very low. On the other side of the spectrum, positive valence, low arousal, maybe you're on your back porch by the fire, you have a glass of wine with some friends, you're chill, you're relaxed, but it's positive. So those are really the four main quadrants when we're thinking about affective states. And generally for improved animal welfare, we would ideally like our animals to spend more time on that positive side than that negative side. Certainly when we're running laboratory animal experiments, they may have to have some time on that negative side of the spectrum. But the more that we can get them back to that positive side, the better. And traditionally, we've attempted to measure affect using things like heart rate variability, or corticosterone, cortisol, but these really measure arousal better than the valence, whether it's positive or negative. So you can have a high heart rate, you can have high cortisol if you are very stressed and afraid, but you can also have it, an animal can have it if they're playing, if they're mating, if they're exercising. And so one of the people who really kind of brought this study of affective states into a new arena, and who actually started rat tickling and how this story all really began, was the late Dr. Jaak Panksepp, who's considered the father of affective neuroscience. He, along with Dr. Jeffrey Bergdorf, were developing techniques to systematically studying the neurological basis of positive affective states. And they were really interested in applying this to figure out what the foundations of human and animal emotions are, study the evolution behind them, but then actually apply them for clinical research for improving different human disorders and using the rat as the model. So to go specifically into rats, adult rats make two main kinds of ultrasonic vocalizations. This means that humans cannot hear them with our normal hearing, but if we use microphones, we can visualize them or bring them down to an audible level. The first type is a 22 kilohertz, which is generally thought to reflect negative affect. What you see up on the screen is a spectrogram where the y-axis is the kilohertz, that's the frequency of the sound, and on the x-axis is time, and that dark bar is the actual vocalization. And if we bring that down to a level that's audible to humans, this is what it sounds like. Maybe? So that is a 22 kilohertz vocalization from a rat. And the evidence that we have that these are indeed reflective of a negative affect is that they're produced in situations that we have a strong reason to believe are negative, such as foot shock from rats, generally not probably something they enjoy, when they are exposed to predator odors, in social defeat tests, and they're also made in anticipation of these events if you pair them, if you classically condition them. These vocalizations are also correlated with typical behavioral ways to assess negative affects, such as avoidance behavior and freezing. And furthermore, if we actually look at the brain circuits that they're involved with, 22 kilohertz vocalizations predict increased cholinergic activity in the brain, which is similar to the pathway that actually is expressed in human fear as well. On the other side of the spectrum, we have our 50 kilohertz vocalizations that are thought to reflect positive affect. This is an example. There's many, many different subtypes. This is a trill, which is a type of frequency modulated one. This is what it sounds like. And these are also produced on the flip side in situations that we would, again, think to be positive, such as when rats are given high-value food rewards when they are hungry. Also, when they're given euphorogenic substances, such as amphetamines. These substances, when applied in humans report very positive affect. Also during rewarding social interactions like mating and play. Again, these are produced in anticipation of all these events and are correlated with typical behavioral ways to assess positive affect, such as approach behavior and conditioned place preference. Furthermore, they also match the neural circuit in humans, and they are reliable predictors of increased dopaminergic activity in the brain. And furthermore, if you actually measure both 50s and 22s, you can see rats shift from producing more 50s to more 22s. So this is the ratio of 22 kilohertz ultrasonic vocalization over the total USUVs. And at the beginning of these encounters, when there's not going to be any reward, they're making very, very low levels. But as they are wanting these encounters to stop and that reward goes away, they're making more and more 22s, which are negative. You can see this shift from 50s reward to 22s. And so because of this, we think that vocalizations could really help us evaluate rat welfare. And that starts to bring me to tickling itself. So as I said, one of the places or times that rats actually produce these 50 kilohertz vocalizations is during play. This is what rat play actually looks like for those of you who may not have seen it before. You can see the rats, they're running around together, they're wrestling, they're jumping on top of each other. It should look pretty rough. It's considered rough and tumble play. And this is just to show you they don't just do this in a test box. They do this in typical laboratory housing as well. So you see this in test situations and in a normal housing situation. And when it boils down to it, rat play really has two key components. A dorsal contact, where one rat jumps on the nape and the neck of the other, and a pin. And that's where rat tickling actually comes from, is rat tickling was designed to mimic aspects of rat rough and tumble play with a dorsal contact and a pin. So this is what rat tickling actually looks like. In the top left corner, there's a bat detector tuned to 50 kilohertz. So that's going to bring those ultrasonic vocalizations down to a level that's audible for the human ear. And so you can see that's pretty rough. That's what it looks like, but that's what it's supposed to look like. It's supposed to mimic that rough and tumble play. And so like I said, this technique was really developed in the field of neuroscience to help study positive affect. But Dr. Sylvie Cloutier, who's one of my collaborators, decided to try to bring it into the field of welfare because of the fact that we know that rats experience stress during handling. Rats are initially afraid of humans. We're a lot bigger than them. We're a lot like predators. And then we do things to them that often aren't very pleasant, like giving them injections, oral gavage, or other negative procedures. And so the rats can become stressed, which can, of course, impact rat welfare, sending them into negative affective states, also potentially impact experimental validity and reliability. And so tickling, we thought, could be used to help ameliorate some of these effects. And so for the first project that I'm going to run through is my systematic review. And I had 3 main questions that I wanted to answer. Does rat tickling really improve rat welfare? What are its outcomes? How should I use rat tickling, both in research and for welfare enhancing techniques? And what factors do I need to pay attention to that might moderate my outcome? So really the goal of this study was to provide a comprehensive overview of empirical tickling research to provide direction for future application and investigation. So we looked at the applications, how studies had used tickling before, the outcomes that they had found in comparison to other conditions, and the moderators. For our methods, we tried to have high rigor and objectivity throughout the review. We followed the PRISMA guidelines, which are the preferred reporting items for systematic reviews and meta-analyses, as well as the CIRCLE guidelines, which is the Systematic Review Center for Laboratory Animal Experimentation. And so these are a set of guidelines that give researchers who want to conduct a systematic literature review a series of steps, what to report, to help minimize the bias in these types of reviews. And furthermore, we actually use the CIRCLE risk of bias assessment tool to then assess the bias of the studies, the individual experiments that we were assessing. And we had 2 independent reviewers look at all of the articles and decide whether they met our inclusion criteria. Unfortunately, because of time, I won't be able to talk about the risk of bias assessment today, and I will only be going through a few of the results, but this work is actually published and it's open access in PLOS One. So we searched 4 major databases for our methods from their inception to August of 2016, and our inclusion criteria was that articles had to be peer-reviewed, experimental studies about rats using the technique of tickling. So I'll jump right into our results. We ended up finding, as of August 2016, 56 different experiments that had used rat tickling in them. This was from about 36 different articles. And we found that a variety of rats had been tickled before. All 4 major stocks of rats, both sexes, juveniles and adults, and rats that had been housed both individually and socially. So what this means is that if you're interested in using rat tickling and any of the rats that you've worked with, it's probably been done in a similar rat before. We also found that rats were tickled for various dosages. So people tickled their rats anywhere from only 30 seconds to 10 minutes per session, from anywhere from 1 to 46 days, but on average for about 2 minutes for 5 days per rat. Now to look at the outcomes, 22 different experiments actually compared the results of tickling a rat to a control or a comparison condition. And really what we found from this review is that rat tickling is an effective intervention. I'm just going to show you a couple of the results that we found. But this is a graph where on the x-axis is the number of the experiments, and on the y-axis is going to be the outcome. Green indicates a positive effect, and gray indicates no effect. For 50 kilohertz vocalizations, unsurprisingly, but also very positively, we find that rat tickling increases the number of 50 kilohertz vocalizations produced versus other comparison techniques. We also find that rat tickling increases rat approach behavior to an experimenter. It decreases generalized anxiety and fear in elevated plus mazes and open field, although this result was a little bit less consistent depending on the study. And it also increased the handling for the rats. So this means that it actually made the handling of the rats a little bit easier for the people doing the handling, but also improved the rats' experience during the handling, which was often measured via 50 kilohertz vocalizations. Now we'll move on to moderators. So 40 different experiments looked at some sort of factor that impacted the results of rat tickling. And I'll just go through one today that I think is the most important for people to consider, and that is of individual differences. We find in study after study that some rats consistently vocalize more than others. 12 different experiments found this result. This is a graph from just one of them that tickled rats for 46 days, and this is the number of 50 kilohertz calls across those days. And what you can see is that they really split into these 2 groups, and there's quite a large range between them. And furthermore, the rats that vocalize more actually respond more positively to the tickling and just in general. So this is a graph from a study looking at cognitive bias in rats just after tickling. The methods of this study, I have some problems with them. They only tickled the rats for 1 day for 30 seconds. But on that day, the very first time they tickled rats, the rats that vocalized during that tickling then showed a positive cognitive bias in their cognitive bias test, while the low callers just showed a neutral bias. It wasn't negative, but it was not positive. Furthermore, the experiments have shown that these high-calling rats have less susceptibility to chronic variable stress. They show fewer anxiety and fear behaviors and have decreased approach latency to the experimenters. So they're just a very different rat overall than rats that are low-calling. And they've actually used these rats for models of different disorders in humans. But just to wrap up this first study, the conclusions from this systematic review was that despite a wide variety of methods, rat tickling does result in many positive outcomes, but these outcomes are moderated by many different factors. And overall, we just found a lot of differences in our studies, and so we thought there really needed to be some standardization. But I'll go into the second project that I'll be talking about today, and that's about determining a practical rat tickling dosage. And the rationale for this project was based on what I said before, that current rat tickling practices are not only not standardized, but they're fairly time intensive. Now, 2 minutes a day for 5 days may not sound like a lot of time, but if you have just 50 rats in an experiment, which is not so many, that ends up being about 5 hours of personnel's time per studies, which is a lot of extra time each week. And so our objective was to identify a practical rat tickling dosage. We wanted it to happen within the 7-day work week. We wanted to look at what the most minimal duration could be. And we wanted to use pair-housed rats because that is how rats are most commonly housed in animal experiments. Our hypothesis was that rat affect and handling could be improved by short daily doses of tickling within a 5-day work week. And our prediction was that 30 seconds per rat for 3 days would be most effective. And we measured this in a variety of different ways, but our primary outcome was looking at those 50 kilohertz vocalizations during tickling and comparing them between treatments. For our experimental design, rats were randomly assigned to a different tickling dosage. So we tested 3 different durations, 15, 30, or 60 seconds. So we chose 15 because that's really about as short as you could probably go for tickling. We chose 30 because it was the shortest that had previously been done in the literature. And we chose 60 because that's most commonly what had been done in the literature before. Because if you tickle a rat individually for 2 minutes, that adds up to 60 seconds of actual tickling per rat. Then for frequency, we looked at 1, 3, and 5 days, again, based on that literature review. In the end, we ended up having 72 rats that were housed in 36 cages across 2 replicates. They were Long Evans strain, male and female, and that led us to an N of 4 cages per combination of treatment factors. And this is a picture of what our housing room actually looked like with the cameras, the rats, and their huts. We assessed rats via a standard intraperitoneal injection that occurred the day after the final day of treatment, and we did pair this injection with a tickling procedure. So this was considered our test day. We assessed rat affect and handling at a couple different periods, so during that tickling session and the injection. We looked at their home cage behavior for 60 minutes before and after, and we did a 30-second approach test before and after. So this gave us an anticipatory period, a period during the tickling injection, and a reactionary period. We took video recordings during this entire time, and we looked at ultrasonic vocalizations during the approach test, the tickling, and the injection. For our measures, for our home cage behavior, we looked at play behavior because in rats, we know they make these 50 kilohertz vocalizations during it, and it's considered positive. We also looked at activity because we know that rats in many laboratory housing are very, very inactive, and this is potentially not as good for our experimental validity and them as models as well. They might be displaying some of that low arousal, negative affect state. And we also looked at their locations. We ideally want to see the rats when the experimenter walks in the room to come out of the hut, be ready to interact. Of course, we looked at those 50 kilohertz vocalizations, and we also looked at those 22 kilohertz vocalizations as well as audible. I will go ahead and note that we saw this very, very few on the test day, and so we couldn't actually do any analysis on it, so I won't actually present those results, because it would just be a graph with no bars on it. We minimize bias throughout the process by blinding our coders to treatment throughout, so they didn't know whether they were looking at a rat that had been tickled for 1 day or 5 days. We analyzed our data via general linear models. We had cage as the experimental unit, and we had a 3rd degree factorial of frequency, duration, and sex, and blocking factors of replicate, rack, tier, and cage. But if p-values were over 0.1, we excluded those interactions and blocking factors in our final analysis. Okay, let's get to the results. They're pretty exciting. We found that tickling for just 15 seconds was the most efficient and effective. And so I'm going to show you this graph. On the x-axis is the duration of tickling, and the y-axis is the vocalizations during tickling. And what you can see is that there's absolutely no difference between whether rats were tickled for 15, 30, or 60 seconds. And what's more, regardless of our outcome measures, we never found a difference between whether rats were tickled for 15, 30, or 60 seconds. So at least from this study, it really appears that duration is not really that important to the rats. It's more about frequency. So if you want to maximize your time, 15 seconds is the amount to choose. Of course, if you have time to tickle a rat for longer and would like to do that, they will be, you will be playing with them more. They will make more total 50 kilohertz vocalizations, but the rate and the other outcomes don't appear to be impacted. On the other hand, our prediction that 3 days would be most efficient and effective was shown to be our results. And so on the x-axis, the only difference is that now we're looking at tickling frequency. And you can see that rats produce about 70% more calls after 3 days of tickling compared to 1. But then this levels off, and there's not really a difference between 3 and 5 days of tickling. And furthermore, we also see that their in-cage play behavior before they experience that tickling, so during that anticipatory period, exponentially increases from day 1 to 3, but again levels off between days 3 and 5. And we see very similar results for our anticipatory calls, activity, and location. So there was multiple outcome measures that seem to allow us to say that tickling for rats for just 15 seconds for 3 days did improve rat affect. And the significance of this project is that it's an over 1,000% time reduction from that standard protocol of 2 minutes for 5 days. So it takes a lot less time to only tickle rats for 15 seconds for 3 days. For our future directions, we're really interested in identifying and possibly trying to change laboratory personnel's attitudes when it comes to rat tickling. So this spring, I sent out a survey to laboratory personnel across the US and Canada. We got over 900 responses. Over 600 of them were rat users. And we're currently using the theory of planned behavior to look at why people either tickle rats or not. And then we're hoping to actually address barriers to implementation. So one of the things that we actually looked at and we assumed that they would say is people say, I don't have enough time to tickle rats. That's why I can't tickle rats. And so that's why we did that dosage project. We're also finding that whether or not people feel like they're expected to tickle the rats or not makes a difference for whether they want to tickle them or not. And also just their general attitudes. So if they haven't heard of tickling before, they're probably not going to do it. If they don't think tickling is going to be an effective intervention, they're probably not going to do it. And so we're really looking at using this survey of laboratory personnel, trying to figure out what those barriers are, what's actually preventing this practice that we know is beneficial. We know that it could benefit rats, but we also know it's not used. And how can we actually get it into those laboratories? And of course, we're going to be doing our workshop tomorrow morning. And so we're really hoping that doing things like that will help. But overall, just to kind of bring it back around, we really feel like rat tickling could help make better science by decreasing those costs of these experiments, by improving rat welfare during the actual experimental process, but also decreasing the cost by potentially making the rats a little bit better models and making our experiments a little bit more reliable. Like I said, this work has been published, so the systematic review is in PLOS 1, that's the top article. The second article is the second one. It's in press currently about practical rat tickling. And then I just want to draw your attention to this Journal of Visualized Experiments, which is also an open access publication. And if you're interested in applying rat tickling and you weren't able to make it to the workshop tomorrow, or you just want to learn a little more, see some videos of rat tickling, this is actually a step-by-step how to do rat tickling. They lay it out really nicely. We have some representative results in there. And so if you want to know more, these are 3 really good resources that you can cite and be published. Another thing that I would like to mention is if you're having problems getting this approved by your supervisors or feel like people aren't taking you seriously because it's called rat tickling, an alternative name for it is heterospecific rough and tumble play, which is the preferred terminology in the neuroscience field. So that's also a way to look for it in the literature or talk about it with your more suspicious colleagues. So finally, I'd like to acknowledge all of the people that make this project possible, all of my collaborators, my committee members, the students that actually coded the videos, our funders, and of course the rats themselves. This is my rat, Georgia, named after Georgia Mason, who was adopted from this project. And of course, you can email me anytime. My websites are at the bottom. And with that, I'm happy to take any questions.
Thanks so much, Megan. That's really interesting. So we actually have quite a bit of time for questions, which is really great. Thanks for taking the time. Tina.
Hi, that was great. I do see the name that is a barrier to uptake, but I don't see that the alternative term was any better. Do you think that there could be potentially some other renaming of it?
So the question was about terminology. I'm just going to repeat back for our online. It's about terminology and saying, you know, rat tickling it really isn't necessarily good, but maybe, you know, heterospecific rough and tumble play is quite a mouthful. I actually like to call it just heterospecific play, which is a little bit shorter, a little bit easier to say. Sylvie Cloutier has also used playful handling. In the literature review, I go through, it's been called a lot of different things. And so it depends on who you're talking to and how you want to convince people about what you want to do. Because rat tickling I like because it's short, it's sweet. Although we're not necessarily really tickling the rats, it immediately puts an image into your head, identifies the species, but there's lots of different options.
I would think it would be very well. Like all serious researchers are going to pay money necessarily for it.
Yeah, and that's why we do try to, and so one of the things is for my dosage project is I actually say practical rat tickling, what did I call it? Determining an efficient and effective dosage of heterospecific play. So if and when we write grants, unless we're writing them specifically for welfare, we generally use heterospecific play. So it just depends on the audience. You always have to think about your audience. So, yeah.
Taking liberty, sorry, just a question in there. How much do you think of that original terminology has sort of harmed this field of research in terms of people not following it up because it is such a fancy term?
So the question was how much I think that the original terminology might keep people from picking up this research. Surprisingly, so in that survey that I just did of over 600 responses, terminology was really not mentioned very often. There was some issues with talking about, people don't take it seriously. And so I think maybe that original terminology could have impacted it some. But I also do think some of the evidence behind it is pretty strong, and it is still being used in the neuroscience field. They just call it a different name. So I'm not sure. So the question was about tickling rats being housed for a depression model and actually being individually housed. So I'll address it in two parts. I'll do the easier part first. So individually housed rats, tickling individually housed rats is great. It actually provides them with a sort of social enrichment using the experimenter, and actually you might even get slightly more positive results from tickling an individually housed rats versus a socially housed rats. As far as how tickling would affect a depression model, that gets a little bit tough because you're tickling them, you are probably inducing, we do think you're inducing positive affect, and if the purpose of the model is to keep the rats in a negative affective states, it may not be a good idea. And so you do want to think about your model, but then again, I think they've also used rat tickling with models of, I don't know if it's been depression or PTSD, but they use tickling to test the drugs, to test whether or not the drugs are working in the rats, and not as a way to improve the rats' welfare, but actually as a test paradigm. So that is one of their outcome measures, is to tickle the rats. So if these depression rats have some sort of treatment applied, you could actually use the tickling as a test to see if that treatment is working, because a depressed rat, would maybe not want to play as much and might not get as much 50 kilohertz vocalizations, but if you can recover that, it might produce more. So it would depend on the model, but I know it's been used as actually a test paradigm before. So. So the question was, if you're housing rats either in pairs or triplets and they're playing on their own, why would we need to do tickling for them? Why would we need to play for them? And the purpose is not, with an individually housed rat, yes, we maybe do want to actually replace that play because they can't get it out any other way. But for those pair and triplet housed rats, the purpose of tickling is not so much to replace the play, because we actually see that play increases from tickling itself, but to hopefully help the human-animal relationship. And more for that, and to help rats be hopefully less stressed, have less negative affect around the experimenter themselves. So, if the rats were just out on their own and never had to interact with people, then why tickle them? But it's fun. But but otherwise, yeah, it's more for the experimenter rat interactions and improving that, or for a test paradigm for the purposes of looking into positive affect in the rats.
Has anyone tried to measure the motivation of rats to be tickled?
Yes. So they haven't done anything where the rats have to push open a door or do anything like that, but they have done tests where they have a little cup in the center where the rats can stay, and if they're in that cup, they don't get tickled. And if they come out, then they do get tickled. And so they find that rats will actually seek out the tickling. They'll decrease the latency and come out specifically to be tickled and stay in to not. And so there hasn't been studies that actually look at the working for it, but there's that. And then they've actually also used tickling as a reward for operant conditioning as well. And so if you can train, rats to do something and use this as a reward, you think it's pretty rewarding. So, good question.
How do you draw the line between play fighting and actual fighting? For example, do the rats make more 22 kilohertz than 50 kilohertz during actual aggressive fighting? Because I have rats on my own, and when they play fight or fight, I don't know, sometimes they squeak a lot, and I don't know if they're hurting each other or they're having fun.
So the question is about how to distinguish between true fighting and play fighting in rats, and whether we look at the ultrasonic vocalizations or not. So in the dosage project that we looked at the different dosages of tickling, we considered any sort of rough and tumble activity with the rats who were same-sex juveniles to be play behavior, because generally true aggression in rats has very different like motor components, and the rats behave very differently in that true aggression. Really that pin and the flip are more for that rough and tumble play rather than the true aggression. Also the true aggression in rats is much more common in adults, particularly adult breeding males. So one of the things that we do tell people is we tell people don't try to tickle your adult breeding males. We've done it before, and that's our one instance of getting bitten when tickling a rat. So, but yeah, generally the studies on rat play look at that dorsal contact, flip in the pin, and the rats will make audible vocalizations during it as well, and that's okay. If you could look at vocalizations during it, that would be great, because if they're making, because what they see during rat play is when rats start playing, they'll start by making lots of 50s, and then like towards the end, they will start making 22s, and that's usually when they separate. So the 50s are thought to tell the play partner, okay, I'm having fun, this is a good interaction, and the 22s are stop. So.
I wonder, I've got two questions. Could you say a little bit about the effects of tickling on mitigating injection stress, or similarly mitigating the effects of acute procedures? And also, has anyone looked to see if you were to tickle rats for a number of days and then stop, do they miss it? Like, it's doing it for a bit and then stopping worse than I'm doing it?
Okay, so the first question is about talking about tickling and injection stress and how tickling can impact that. And so the studies with that, they've looked at tickling a rat before giving an injection, tickling the rat before and after giving an injection, and tickling a rat just after giving an injection to see like what timing is best. And mostly what they found is that before and after, but again, if we're thinking about efficiency, which is often prime in the laboratory animal field, before an injection is best, because, and the thought is that maybe after the injection they're a little bit sore, they maybe don't want to play, but in those studies they do find that if you tickle a rat, you give an injection, and then you let it go, it will continue making those 50s. During the tickling, of course. Actually, in my study, we found a lot of 50s during the injection procedure. We actually found no differences between our treatments. Even our rats that were only tickled for one day were making quite a few 50s, which we think might have been because how we restrained them for the injection was similar to how they're being tickled, and so they're used to being handled like that, and they actually associate it with play. And then afterwards they'll make the tickling or make the more 50s. So, and they'll be more likely to move around, whereas if you have a non-tickled rat after injection, they'll be more likely to freeze or avoid the hand that just did something nasty to them. And they do see this across if you give injection for like 10 or 20 days over and over and over again, again, which is common. And then your second question, I already forgot it. Oh, yeah. Yes, so if you tickle the rats and then you stop, do they miss it? We don't have a study looking at that per se, but we do have a study that tickled rats when they were either tickled or didn't tickle rats as juveniles. Stopped tickling them, waited until they were adults, and then either tickled or didn't tickle them using a factorial design. And you actually saw the most benefits from those rats that had been tickled as juveniles and tickled as adults. So that doesn't necessarily say whether or not they missed it in the interim, but they were happy to get back to it at the end. Whereas the rats just tickled as adults, still you saw benefits. And the rats that were just tickled as juveniles, you saw some, and the ones not as all, you didn't see as many. So there does seem to be this dose. And I'm not sure. I mean, what we would recommend is, so from our dosage project, is what we would recommend is that you get that 3 days of baseline where you consistently come in and tickle the rats for 15 seconds, and then you tickle them before a cage change or before you do an injection, just when you're in the cage anyways. You know, if you're just walking in the room to do a health check and looking through the cages, it's probably not necessary to pull them off every time, but if you're gonna be in there anyways, take 15 seconds, it's pretty quick. That would be our recommendation, so.
Megan, we have lots of terms in animal welfare science to describe negative affective states, and we seem to have fewer on the positive side. How do you talk about the affect related to positive physical contact or tickling or whatever?
So the question was about, we have a lot of terms for negative affective states in the welfare field, but we don't necessarily have as many terms for that positive affective states. And how could we talk about the specific words for that, for tickling? We would think that they would be that high arousal, positive affect quadrant. And so some people have talked about the rats feeling joy. Again, kind of thinking about human play, what things would humans self-report during some sort of playful interaction. They might say, I'm feeling joyful, I'm feeling happy. Generally, we don't getting that specific granularity of what sort of emotion word gets a little dicey. But I think joy has been used before for tickling. And there's actually been, Jaak Panksepp was a proponent that he thought that these 50 kilohertz ultrasonic vocalizations were analogous to human laughter. That if you go through the evidence and you compare the two across different situations, that there are some similarities, and there's a really interesting review paper on that if you're interested. So.
Has this area of sociability been studied or attempted to be replicated by humans and any other species or other species of rodents?
Great. So the question was about whether this research has been replicated in any other species of animals, correct? So I actually have a slide for that. Can I tickle other laboratory species? Because this often comes up. The short answer is no. Rat rough and tumble, the tickling is based off of rat rough and tumble play. So it very specifically mimics the rough and tumble play of rats. Mice, if you try to tickle a mouse, it will bite you. It will almost certainly bite you because mice don't play like rats. They don't do this rough and tumble play. They do this popcorning. It's not the same. However, the longer answer is that although it hasn't been done, if we can find ways to mimic play, to try to find a way to appropriately mimic key aspects of play in animals, that does have potential because, at least in species that we think that, they are enjoying their playful interaction. So it has potential in general, but you really need a species that actually socially plays in order for it to be effective.